Students, I am your teacher. This is Mr. Cockbrenner coming back at you. We are solving quadratic functions, putting that fun in functions by completing the square and square root. So hopefully today's lesson, as you can see on my tabs up here, I have 1, 2, 3, 4, 5 tabs for Desmos up there. So you can see what we're already going to be utilizing a lot, our bestie still, in Desmos. All right, sit back, relax, enjoy the show. Here we go. All right, solving quadratics by square roots. Number 1, isolate the x squared with inverse operation. All right, so make it say x squared equals. Then step 2 is take the square root of both sides. So we're going to take this x squared, and the only way to undo a square is by taking the square roots of both sides. And what happens on the right side, you're going to get a plus and a minus combo. The plus is your right, the minus is your left, because when you take the square root of something, negative times a negative gets you a positive, positive times positive gets you positive. So that's the whole idea of undoing the square root. And then step 3, you're going to get x equals. X equals the right, x equals the left. All right, we'll show you what that looks like here when we do the problems. All right, so as you can see, I've kept our notes down here just so we can check it off. If you look, it says isolate the x squared. So I have 4x squared equals 400. So the very first thing I must make it say is x squared. So how do you undo 4 times x squared? Undo multiplication through division. Good. So now we get x squared equals what's $400 divided up to 4 people. Each person gets $100. Good. And that's step 1. Step 2 says take the square roots of both sides. So I square root this side and I square root that side, and I get x equals, anytime we do that square root, it's plus or minus 10. What does that mean? It means it's either negative 10 or positive 10. All right? And think about it. What's negative 10 times negative 10? A positive 100. And then what's 10 times 10? Positive 100. Okay, any questions? I have 2 answers. All right, it's going to be 10 or negative 10. If you notice, how many terms are actually here? We have our quadratic term and our constant term. So this is a quick section because we're missing our linear term, the one with the x, okay? So it's kind of a dead giveaway what our answer is going to be. And here we have 2 solutions. So here, the first step we have to do, again, is isolate the x squared. Is that by itself? Nope. We need to subtract 7 from the left. Whatever we do to the left, we do to the right. We have elimination here. Now I get x squared equals what 7 minus 7 is 0. What's this? Now that I have it isolated, I take the square roots of both sides. I get x squared. Square rooted is x always, because x times x gets you x squared. So taking the square is undoing the squared. Taking the square root, I should say. And then what's the square root of 0? So this is plus or minus 0 technically, but since 0 does not have a plus or minus, it's just 0. It's a special number. This is a 1 solution. Remember, it touches the x-axis in one spot, and that's going to be the origin. Next. Here, the dreaded F word, the fraction. 25 divided by 36, right? So here, isolate, get the x squared by itself. Does the left side say x squared equals? It does. So what do? Step 2, take the square roots of both sides. So if I square root this side and I square root this and this, what do I get? I get x on the left equals a plus minus combo, because you need the left and the right. What is the square root of 25? So 5 is going to be in my numerator. What's the square root of 36? 6. So x equals plus or minus 5 over 6. So there's 2 solutions for this problem. Negative 5/6 and positive 5/6. All right, so 2 solutions. Next problem. I need to isolate with using inverse operations. So I have my quadratic term there. So my 5 is x squared's best friend. We're going to stay that to the end. So let's subtract 3 from both sides. And we're going to get 5x squareds left on the left. And I had $128. I spent 3. Now I have $125 left. And now I'm taking 5 times of x squared. So I need to divide both sides by 5 because I'm isolating it to make it say x squared equals. So I get x squared equals, what is $125 split between 5 people? $25 each. Since I did that, I've isolated it. Now I take the square roots of both sides. What's the square root of x squared is x. The square root of 25 is, we already did that right here, was 5. And remember, anytime we do that square root action, we get a plus and a minus. So we have 2 solutions again here. The left arm and the right arms. The left is -5 and the right is +5. If you look here, I'm going to isolate. I'm not going to go through my steps because I think I'm pretty good right now. And I get 49x squared equals 64. Divide by 49. And here's where I'm not going to want to simplify that fraction because it's pretty ugly. So now I get x squared equals 64 divided by 49. If you notice, there's a lot of pretty numbers. In my classroom, I listed them on the front board. Remember, we just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we just did 1 squared. 1 squared was 1. 2 squared was 4. 3 squared was 9. 4 squared was 16. 5 squared was 25. So we're going to get that list of pretty numbers. And if you notice, a lot of these are pretty numbers because we're learning how to do it. So we're going to get you good answers. What's the square root of 64? 8. What's the square root of 49? 7. And remember, anytime you do this square roots, we get a plus and a minus combo. So it's plus minus 8 over 7. So I have 2 solutions. It's x equals 8 over 7. That's the right. And then the left would be -8 over 7. So 2 solutions for that problem. Here, I'm going to isolate by subtracting 100 because I'm going to get rid of that constant first. So I get 9x squared equals 100. Divide this by 9, divide this by 9. X squared equals -100 divided by 9. I actually didn't do this in Desmos. So let me just do that real quick to show you what's going to happen. I get, this whole mess again, -100. If I try to square root that, what happens? Actually, I have to put it underneath that radical. It's undefined, so I'm just going to erase this. Why is it undefined? I haven't even done the denominator yet, but why is -100? Why can't that be square rooted? Why can't that be defined with a value? That's what it means to be undefined. What number times itself gets you a negative? What's a negative times a negative? It's a positive. What's a positive times a positive? It's a positive. So there's no way we can get a negative under a square root, all right? That just can't happen, all right? You cannot take the square root of a negative because, like I said, a negative times a negative is a positive, and a positive times a positive is a positive. So the only way to square an answer or take the square root of something has to be positive, okay? Because it's not definable. You can't figure out a value that does that, all right? Here, be careful. I chose this one just because it's a little bit trickier. Subtract 90. Subtract 90. I get -3x squared equals -90. And because of that trick I just taught you about, you can't take square roots and negatives, you see right now that there's a negative right here. So some of us are like, well, he just taught us that you can't take a square root of a negative. Be careful. We haven't isolated and made it say x squared equals. So when I do that, what's a negative divided by a negative? Right? It's a positive. How many times does negative 30 or negative 90 get divided by negative 3? 3 times, right? So we get the square root of positive 30. So I get x equals plus or minus. What's special about that number, though? That number's pretty ugly, right? So when I get that, I'm going to get square root of 30. And I get this crazy decimal. It's called an irrational number. So what I'm going to do is just leave it plus or minus the radical 30. All right? Any questions? Leave it as is. If you look for equivalent forms, anything that you put in, as you can see, it's going to get you that decimal. 5.47722557505. Okay? So anything that's equivalent obviously is going to make that decimal appear to that value. All right. So now we have something a little bit crazier. All right. This looks like vertex form, right? Remember vertex form? I can show you on this page right here. Maybe. Where is she at? There it is. Here's my vertex form. Y equals a parenthesis x minus h parenthesis squared plus k. So I go to that vertex. Let me just scroll back over here. Here's my vertex form. I have this 7, which is really negative 7, right? Because we take the opposite of inside. And then I have to move 81 back over for the k value. However, if you do have something that looks like this, we are going to isolate the x in parentheses squared. So you can see what I'm looking for is this on the left side, which I have. So what's the second step? Is take the square roots of both sides. So when I do that, remember anytime I do that, I'm going to get that plus minus combo over here. What's the square root of 81? It's 9. What happens when I take the square root of this binomial here? It just drops the parentheses essentially. So now I really have two statements here. I have x plus 7 equals 9. And then I have x plus 7 equals negative 9. And now I need to solve for x. How do I move 7 to the other side? Make it negative, and I get x equals 2. And on this side, I subtract 7. It's the same step as you can see right here. And I get x equals, be careful, because you have a negative and negative. If I owe you $9 and you just bought me lunch, which was $7, I now owe you negative $16, right? So we have our two solutions for that. Let's practice one more. So again, we need to isolate and make it say that binomial squared equals. So the first thing I need to do is say it's not by itself. So I'm going to subtract 12 from both sides because this now cancels out. So now I'm left with x minus 4, the binomial being squared, making the perfect square trinomial, equals 144. Since I did this, I take the square roots of both sides. So now I get x minus 4 equals positive and negative 12 because it's plus or minus the square root of 144. So I'm going to put this as my minus 12 and then do x minus 4 and solve the positive 12 on this side because there's two solutions here. That's what that plus and that minus means. So I'm going to have to do two problems here. How do I isolate the x and solve for x? Make it say x equals. I add 4 to both sides. And what do I get? X equals, this eliminates. Negative 12 plus 4, I paid back $4 that I owed you because I owed you 12. Now I only owe you 8. Here we're going to add 4 to both sides again because we're going to isolate x. I get x equals 12 plus 4 is 16. So again, I have 2 solutions to this quadratic equation. We're missing that bx, that linear term again. However, I solved it by doing square roots. Word problems, your favorite. I know. The area of a square. Again, a lot of you don't want to use this Jinkies, Scooby, right? There's a clue here. It's a square. It tells me so. The area is 40 inches squared inside. The length of each side is 2x. All right, well, how do you get the length? It's side squared, or length times width. What's 2x times 2x? 2 times 2 is 4. X times x, add your exponents. 1 plus 1 is 4x squared. And that equals your area. What is your area? 40 inches squared. Isolate. Remember, we're going to get to say x squared. So I'm going to divide this by 4. Divide this by 4. And I'm going to get x squared equals 10. And I square root this, and I square root that. And I get x equals the positive or negative of radical 10. All right. Any questions? Any questions? If you need to see it again, remember, always pause, rewind, and go from there. Complete the square to form a perfect square trinomial. How do I do that? Here's my a value is 1. My b value is negative 16. And my c value, I don't know. That's my Mario coin box right now. Ching, ching, right? I'm always looking for that magical mushroom with the red top to make me grow. If you know who I am, I'm a short person. So I always look for that magical mushroom that'll help me grow like Mario does when he runs into it, I guess, right? So how do we do this? It's real simple. We're going to take the b value, cut it in half, and then whatever that answer is, we're going to square it. So again, the only thing we don't know in this equation is the number b. And by number b, I mean letter b. What is your b value? It's negative 16. See where I got it from? It's that linear coefficient. Cut it in half. What do you get? What's negative 16 cut in half? It's 8. What do I have to do now? Square it. What's negative 8 squared? Negative 8 times negative 8 is positive 64, because the only way to get this to be positive, a negative times a negative, or a positive times a positive. Any questions? So again, what's my c value here? How do I get it? It's take b, cut it in half, and square it. So I need this b value right here, which is 50. What's 50 cut in half? Because you always do parentheses first. 25. What is 25 squared? 625. Good, I heard it in the back there. All right, that's for you, Bova. So now I get 625 is that c value. And of course, it's positive because the only way to get this to be a perfect square trinomial is if the c value is positive. Because a negative times a negative, again, is a positive, and a positive times a positive will get you positive. Rewrite each equation in vertex form, aka complete the square. All right? So here's my quadratic. What do I need to do to this quadratic first? Set it equal to 0. Very good, class. I'm impressed. So what do I need to do to set this equal to 0? I need 80 to go away. How do I make 80 go away? What's the opposite of 80? Yeah, subtract 80. And it doesn't combine with an x squared because that's a quadratic. It doesn't combine with the negative 2x because that's a linear term. It makes its own term. It's a constant, right? So now I have this equation set up. When I rewrite each equation in vertex form, aka complete the square, I don't know why it didn't show up over here, but I get y equals a times h minus x minus h squared plus k. I have it on my other slides. I missed it on this one. So right away, I know what my a value is because what's in front of x squared. So I'm going to also do one other thing right here. If you recall from last slide or last presentation, last video, we set y equal to 0. So I'm going to say 0 equals, there's no a value. Technically it is, it's 1. And I want to have x minus h and k. Well, where am I going to get my h and my k? Real simple. I already have it queued up in Desmos, right? Here's my h and my k. 1 and negative 81. All right. So 1, I'm going to take the opposite of 1 and make it negative 1. That's what this negative does here. And then I had negative 81. So if you notice, now what do I have to do? Oh, this is just putting in vertex form. Sorry. So there's your vertex form. Does everyone see where I got this k from? I got that k from the hk value here. H is 1. K is negative 81. So my negative 81 is right here because my vertex is hk. And then, of course, if I look here, I have positive 1. And I take the opposite and make it negative 1. All right? Didn't know if I was going to need more room to work. Rewrite the equation in vertex form, aka complete the square. So what do we need to do? If I look here, here's my a value, here's my b value, and here's my c value. I don't need a, or I don't need b or c, I just need a. So I know that it's going to be y equals, or it could be what? Technically 0, because that's what we're setting y equal to. My a value is 2. And when I go to my Desmos slide over here, I get 2x squared plus 4x minus 70. I get that as my vertex. Where does the vertex go? It's x minus, and that value is negative 1. So what's the opposite of negative 1? Positive 1, so it changes that. Remember that shift changes it left. I square that here. Did I forget to square it over here? Nope, I did. And then what do? I put my plus k. What's my k value here? Negative 72. So actually that's going to be not plus minus, just because we're going to look official here, minus 72. So again, if I rewrite this in equation form, vertex form, I have it right here. Remember, this is always the opposite of what it says for your x value. H comma k, x comma y, right? It's just a specific point that we're talking about. That's why we call it h and k. So what's the opposite of negative 1? Positive 1, and keep your k value the same. Rewrite each equation in vertex form, aka complete the square. So what do I have to do here? I'm just going to rewrite y equals, what's my a value? It's right here, it's 1, so I technically don't need that. Outside the parentheses, I'm going to have x minus, take the opposite, and then plus whatever k is. So let's look at that one. Here's my point, negative 4, negative 5. So when I go here, what's the opposite of my x? What's the opposite of negative 4? Positive 4. And then what's my x value? Was negative 5. So this says plus negative 5, which looks a little weird. So let's just erase that plus sign. And there I have my vertex form, aka complete the square, because this is your perfect square trinomial. That's what we keep saying by complete the square. Solve the quadratic equation by completing the square and then taking the square roots. So the first thing we're going to do is put it into that vertex form. And I believe, yep, I have that right here. 4 comma negative 3. So if I put this in vertex form, I get y equals, what's my a term for my standard form? 1, so I don't need that really. I could if I wanted to. X and square, what was my vertex again? The opposite of 4, so it's going to be -4 inside the parentheses because it's the opposite of that. And then my k value is -3. So now this says taking square roots. So we need to solve this one. How do we solve it? We need to isolate my parentheses and then take the square root. So how do I move this +3? How did -3 cross the road? It became +3. And we're going to set this y equal to 0 as well. So it's 0 equals parenthesis x minus 4 squared. Sorry, I was adding this 3 here. So I add 3 to the right. I need to add 3 to the left. What's 0 plus 3? So it's 3 equals x minus 4 squared. Are my parentheses isolated? So now what do? I take the square root of both sides. Ooh, yucky. I don't like that at all, right? What's the square root of 3? It's just going to remain plus or minus the square root of 3. What's the right side going to simplify to? X minus 4. Remember, we have two answers here because we have two arms to our parabola, the left arm and the right arm. So I'm just going to bring this over here. It was plus minus 3, radical 3, equals x minus 4. So I just took what we did down here and transferred it to the next slide because I ran out of room. Now, how do I solve this? I get x minus 4, and then I'm going to make this positive radical 3. And then I'm going to make it negative radical 3 on this side and set it equal to x minus 4. Because remember, I have the left arm and the right arm. This is my left arm because it's the negative one, right? And this is the right arm of the parabola. How do I add 4 or move 4, negative 4 to the other side? I add. What's the problem here, though? They don't combine. So I'm going to put the 4 out front and then say add radical 3. And I get that equal to x. And then for the left side, again, I'm going to add 4 to both sides. Again, this radical does not simplify. So I'm going to get positive 4 minus radical 3, which is a slight difference because this is a plus. On the right side, this is the negative part, equals x. So these are not very pretty values, and I can show that to you. Was right here. These are not pretty values. So I may have skipped that for this one. Well, it doesn't matter. So these are not pretty values, 2.268. So if I just type this in here, I get 4 minus radical 3. And I get that value right there. Okay? And if I plug in 4 plus radical 3, what's going to show up is this same value over here. So I can even check it with graphing. Always check with graphing. All right? This one, it says solve the quadratic equation by completing the square. Remember, this is putting it in vertex form. So again, when it's in standard form, I'm just going to take that a value from standard form, and I'm going to get y equals 0. So I'm just going to set it equal to 0 real quick. I take this 1 and put it in front. 1 times anything is the anything. That's why I don't need that really. I get x. Here's my vertex for this problem, x squared plus 6x plus 34. I already had it plugged in there. What's the opposite of -3? That's going to get us our plus 3 here. And then my k value stays the same, so it's plus 25. If I solve this, forgot my squared, sorry. I'm going to move and isolate that parenthesis, that perfect square by trinomial. And I'm going to get -25 on this side equals x plus 3 squared on the right. Square root both sides since it's isolated. And again, if you look, don't fall for the trick. You cannot take the square root of a negative. So guess what? I have this zoomed in. So you might think that the x axis is up that way. But guess what? We're getting larger and larger. So if I hit home, guess what? My parabola is up there. How many times does that parabola touch the x-axis? It doesn't. And we know that because we can't take the square root of a negative. So that means there are no roots. There's no solutions. And I can prove it one more time by zooming out. It doesn't touch the x-axis. It's way up here, right? So anyways, the best part of the lesson, the last slide, the best slide. Why? Because it's over. Solving quadratic functions, completing the square and square roots. All completing the square means is put it in vertex form using your best friend Desmos. As you can see, we have those 5 tabs open on the left. And again, if you like it, thumbs up, subscribe. Other than that, good luck. Ask questions, email, rewind. We'll help you out. All right, we've got your back. Here we go, brownies. Here we go.